Hello student, welcome to my class. Today we will start a new chapter, that is optics, and here we deals with the nature and phenomena of light. So first thing is that what is light? Light is one type of energy which make an object which is visible to us, and that is known as light. That means actually light is the combination of electric field as well as magnetic field. Suppose this is the direction of electric field which vibrate this direction, and suppose magnetic field which is inward direction. That means then the perpendicular direction of, and this direction which is direction of speed of light, and this is the direction of light. So it is the combination of both electric field and magnetic field, that is known as light. Again here we deals with, or here we have to study about, that is diffraction, reflection of light, polarization, etc. Clear? Because this light is the basis of electromagnetic wave, and that wave is known as electromagnetic wave. And if you want to study electromagnetic wave, we will discuss next class or upcoming class. Suppose here you already know that is what is radio wave. This is radio wave, next microwave, and next infrared region, and here one region which is known as visible region, and that region is known as, it is visible, region. And here 7 color of light concept, that is VIBGYOR, VIBGYOR. And again if you come to the next part, then here we will face, that is electromagnetic wave, and next that is X-ray, and next gamma ray, and so on. Clear? And this spectrum is known as electromagnetic wave. So what is light? Light is that part of energy, or light is that part of region which is visible to us, or light is that part of electromagnetic wave which is visible to us, is known as light. So this combination of electric field and magnetic field. If you come this side to this side, then we already know velocity equal to distance by time. So what is velocity? But here we will discuss about light. So here we have to take, that is v equal to speed of light which is equal to distance. Distance means here we have to take lambda, which is distance, and divide by time, or c equal to, we can write 1 by time period which is equal to frequency. So c equal to hf. C equal to lambda into f. What is lambda? Lambda is here wavelength of light, and what is here? F is here frequency of light. Clear? So if you come this side to this side, that means if you come radio wave, microwave, infrared, and in this way, then in this direction the wavelength of the light decrease. That means here the wavelength which is equal to 6700 angstrom, and here which wavelength here 3600 angstrom. Clear? Okay. But speed of light in vacuum, which is constant quantity, if lambda increase or if lambda decrease, then frequency increase, because C is constant quantity. So if you come this side to this side, wavelength of the light decrease, and this wavelength, and between this wavelength the light which is visible to us, and that region is known as visible region, and its wavelength 3600 angstrom to 7600 angstrom. Clear? Okay. And if you come this side to this side, here frequency increase. Why? Because wavelength here wavelength decrease, that means frequency increase. Wavelength decrease, and here frequency increase. This is known as light. But here we will discuss about what is optics. Actually here we have to study the nature and phenomena of light. So optics is categorized, or optics is divided by two parts. So what are they? So there is two part optics, and first one, that is ray optics. This part is known as ray optics, or it is known as geometrical optics. Geometrical optics or ray optics. Similarly, the second part, that is known as wave optics. Wave optics. Clear? So in ray optics, here we will discuss the light in the form of ray. So here we discuss the light in the form of ray, but here we deals with the light which is formed in the form of wave. And again here the light, the wavelength of light lambda, which is very small. Lambda is here very small as compared to the dimension of an object or obstacle of an object. That means here we deals with macroscopic object, macroscopic case or macroscopic object. Clear? But in wave optics, here the wavelength of light lambda, which is very similar, that means which is lambda is similar to the dimension of an object. Dimension of an object. Clear? Next thing, here we will study the phenomenon of light like refraction. Here we will study the propagation of light or rectilinear propagation of light. That means the light which propagate in a straight line. But here, and next thing, here we will discuss what is reflection of light and what is refraction of light. Reflection of light. Clear? So these are the important terms related with ray optics. But in case of wave ducts or wave optics, here we will discuss the wave or light in the form of wave, and in this case we will discuss about that is diffraction of light, that is polarization, and next interference of light. That means here we deals with macroscopic object, but in this case here we deals with that is a microscopic object which is not visible to our naked eye. So we need any optical instrument to see this object, and that is known as a microscopic object. Here it is microscopic object, and this is the physics, thus like that is known as quantum physics. Here we deals actually the main part of this physics or wave optics, that is known as quantum physics. Clear? So these are the separation or these are the difference between ray optics and wave optics. Clear? But here we will go for what is ray optics and their properties. Clear? So next we will start term related with light, and first term that is source. So what is source? Source means which emit light in all the direction. Suppose one example, you have take one example like electric bulb, tube bar, and these are the example of source because it emit light all direction to the surrounding. So here the source means it emits light in all the direction to surrounding is known as, it's called source. It's called source. There is a different type of source. That means first one, it is known as luminous source. And second one, that is non-luminous source or illuminance source. Non-luminous source. Clear? So what is luminous source? And this type of source which have which emit light of its own. That means it possesses light. It possesses light of its own, and it emit light of its own. That type of source is known as luminous source. And the example of luminous source, that is sun, which emit light of its own, and electric bulb, that is electric bulb is one of the example of luminous source. Or you can take tube light. These are the example of luminous source. Clear? That means these are the source which emit light of its own, and that type of source is known as luminous source. And second one, that is non-luminous source. Non-luminous source means it does not possess light of its own. Clear? So these are the source which does not possess any light of its own, but it receives the light from external source. Suppose there is a non-luminous source, and the example of non-luminous source, that is suppose moon. Moon is one of the important non-luminous source, and it's receive light from external source. Suppose there is sun. But sun, what is sun? Sun is luminous source, but moon is non-luminous source. But this moon receive light from sun, and it scatter light to the surrounding, and it scatter light to the surrounding medium. Clear? So the moon is known as non-luminous source. Clear? Next, another term, that is medium. So what is medium? Medium means the region which light propagates. So, and that region is known as medium. What is medium? Medium means, second term, medium means it is the region, it is the region where light propagate, or where light travels. Light propagate. Clear? So this medium, which is divided by three parts, and first part, here there is second part, and this is third part. So first part is known as transparent medium. Transparent medium. That means the medium which allow the light to pass through this region. Suppose there is a medium, and this medium is suppose air medium, or this medium is glass medium. If we incident a light here this direction, then light propagate this direction. That means this region where light propagate, and that region is known as transparent medium. That means maximum, most of the light are preferred to pass through this medium, and that medium is known as transparent medium. That means most of the light pass through this medium, and this medium is known as transparent medium. So example of transparent medium, that is glass is one of the important transparent medium. Second one, water is also a transparent medium. Clear? And air is also the transparent medium. So these are the example of transparent medium. That means maximum light travel through this medium. Next will come across, that is translucent. Translucent medium. So what is translucent medium? And in this medium, part of the light, that is light passes, it is the medium, it is the medium in which light passes partially. Clear? So partial, that means part of the light pass through this medium. That means maximum light do not prefer to pass through this medium, and that type of medium is known as translucent medium. Clear? That means suppose there is a medium like this, and we already know light is the form of energy, and suppose this is the direction of light, and suppose light is the form of energy. So if 100 joule is incident here, then part of the light which is transmitted this direction, or part of the light which travel through this medium, part of the light, it may be 40%, it may be 50%, it may be 30%, and that type of medium is known as translucent medium. So better medium as compared to transparent and translucent medium. So transparent medium is better for propagation of light wave or propagation of ray of light. Here, and the example of translucent medium, that is tracing paper. Tracing paper is one of the example of translucent medium. And next one, that is opaque. Opaque medium. And what is opaque medium? It does not allow to propagate the light. That means here the light do not pass through one medium to next medium, or here light do not allow to pass this medium, and that type of medium is known as opaque medium. Or you can take example, suppose the example of opaque medium, that is wall and mirror. These are the example of opaque medium. Why? If you take the example of mirror, we already know, suppose there is a mirror and one side of the mirror is silver coated, and if we incident a ray in this direction, then this ray will reflect back to its original medium. Clear? So that means here light do not travel this direction, and this medium is known as opaque medium. Clear? So these are the example, or these are transparent medium, translucent medium, and opaque medium is known as medium. Next we will come across what is ray. So next term, that is ray. Ray means it is the path of light. It is the straight line path of propagation of light. Propagation of light is known as ray, and it is represented by a straight line, and there is a arrow mark here, and which is represented as a ray. Clear? That means suppose we have one electric bulb here, and it emit light in all the direction, because light propagate in straight line. That means this is the direction of light, and these are the propagation of light, and these are the rays. Clear? These are the straight line, and this is also known as ray of light. Clear? Next we will come across that is beam. Beam means it is the combination of ray which propagate in a medium with straight line direction. That means it's the combination of ray or a group of ray which make a beam. That means suppose there is one ray, and here second ray, and there is another ray, third ray, and fourth ray. That is this group of ray which make a beam of light. Clear? So these are the beam of light, and these rays are parallel to each other because the width of here this point and width of this point and width of this point are equal. So these are the parallel ray or parallel beam. These are parallel ray. Clear? And this total combination is known as beam. That is beam. So group of ray which make a beam and they pass through a straight line in a medium. Clear? Next we will discuss about that is a different type of beam. So first we will discuss that is convergent beam or convergent ray, and next one that is divergent ray. So first we will discuss that is convergent or converging ray. Convergent ray, convergent beam or convergent ray. Look at this diagram here. These rays are which are parallel to each other and they are moving and they are propagate in a medium, and this is the width. Here the width are equal, and A point and point B and point C are width are equal when these rays are proceeding forward. But if these rays are like this, that means here the width of beam decreases while propagate forward, while proceeding forward. While proceeding forward, and that type of beam which is known as convergent. They are converging to a point. They are converging to a point. That means here width is this, where width is 1 meter, suppose 1 meter, and width can decrease and decrease and decrease, and they terminate and they are approaching towards a point, and that type of beam is known as convergent beam. Clear? Next and second point, that is known as a divergent beam. So next one, it is divergent beam or divergent ray. That is divergent beam. Clear? And in this case, the rays are coming outward direction, or the rays are coming from one direction and moving this direction. Clear? These are divergent ray, because here the width of beam increases while proceeding forward. While proceeding forward. And that type of beam is known as diverging beams. Clear? They are diverge in all the direction. Suppose there is a point source, we already know if there is a point source, it emit light all the direction. These are the direction, or these are the ray of incident, these are the ray of a source, like this, and these are also known as divergent ray. Divergent ray, because they are diverse from a point, and width of this ray or width of this beam increasing while they are proceeding forward direction. Clear? So these are the separation between convergent and divergent beam. Next we will come, but in case of ray optics, we will discuss here only monochromatic light. What is monochromatic light? Here, there is a term, that is monochromatic light. So what is monochromatic light? That means there is a number of rays and which form a beam, and here the beam of light or all the rays are coming with a single wavelength. Single wavelength, and that type of ray is known as monochromatic light, and here the beam which consists with a single wavelength. Clear? Okay. Next, will come across what is reflection. Reflection of light. So next, the important term related with optics or ray optics, that is reflection. Reflection of light. So what is reflection of light? Suppose there is a medium and this medium which is separated by and this boundary. Suppose there is a boundary and this boundary which is separated by two medium, and there is, this is medium number 1 and here medium number 2. Clear? So suppose there is a source which emit light all the direction, and take one ray which is coming this direction. This is one ray, because ray which travel in a straight line path. This is ray, and here there is a source. Suppose this point is S, and this is boundary. Clear? And this point is striking point, and this point A, and this point we can write, that is point O. And the incident ray, this ray is known as incidence ray, which coming from this source and which strike the boundary at point O. If you draw a normal, at the incident point, then this normal which is perpendicular to this boundary, or this normal which is perpendicular to this surface. Clear? This is incident ray which incident at point O, and here we have a normal, and that is N. N means that is known as normal. And what is normal? This is perpendicular line, and this perpendicular line which is make an angle 90 degree with this boundary. Clear? Now some part of light which is reflected back to its original medium, because light which is coming from first medium, and after reflection, after incident at point O, it reflects back to its original medium, some part of light. Clear? And that ray is known as, that is reflected. That is reflected ray. Clear? Because there is two medium and there is separation and they are separated by a boundary, and here the light bent in this direction. Because we already know light pass straight line for a medium. If there is any interface or any boundary, then they change the edge of the boundary or the bend at the edge of the boundary. And suppose this ray travel this direction, some part of light travel this direction, because light is the form of energy. Or you can say that suppose here the light incident 100 joule and 80% or 80 joule light reflected to the original medium, and rest light which is transmitted and which is transmitted to this medium, that is 20 joule. Clear? And this ray is known as transmitted. Transmitted ray or refracted ray, or you can say that is refracted ray. Clear? Okay, this ray, that is refracted ray. Okay, if we draw a straight line, because this is incident ray, if we draw a straight line as compared to the incident ray, then this light pass through this direction. Clear? We will discuss, we will come to that part after some time. So this is refracted ray, this is incident ray, and this is reflected ray. So what is reflection of light? Reflection of light means when light incident on a boundary, then part of the light is transmitted to second medium, and that ray is known as refracted ray, and the remaining part of the light which is reflected back to its original medium after being obstructed from a boundary, and that is known as reflected ray, which reflect back to same medium, and this angle is known as angle of incident. And what is angle of incident? Here angle of incident I, and which make It is the angle between. It is the angle between incident ray and normal. Clear? I is the angle between incident ray and normal. Next, this angle is known as reflected ray. Reflected angle, or this angle is known as angle of reflection. Clear? And the angle of reflection is the angle between reflected ray and normal at this point. Clear? And there is another two angle, this angle and this angle. This angle is known as, or this angle is known as, it is known as glancing angle. Glancing angle, or it is known as grazing angle. Grazing angle. So what is grazing angle? The angle made by incident ray with boundary or surface of the boundary, and that angle is known as glancing angle or grazing angle. Clear? These are all about reflection of light. So first we will discuss what is law of reflection. There is two law, first law and second law. Suppose we have a plane mirror, and here suppose there is a plane mirror, and the plane mirror M and M dash, one of the side which is coated with silver, or one of the side is silvered. Now this side is reflecting side, and suppose there is a source or object which incident light this direction. This is known as incident ray, and suppose it take to that is incident ray, and the light which striking on the mirror, suppose this point O, we have to make a normal at this point, and this angle is known as angle of incident. After incident this point, it reflect back to its original medium. If light reflect back to its original medium, make an angle R, and this R is known as angle of reflection, and this light is known as reflected light, reflected ray. That is reflected ray. This angle is glancing angle. Clear? Okay. But according to reflection law, there is two law, first law. So what is first law of reflection? The incident ray, reflected ray and normal all are lies in one single plane. Clear? And that plane which is perpendicular to this mirror. Suppose there is a plane like this, and this plane which consists incident ray, here there is a normal and there is a reflected ray. Clear? This is known as first law of reflection. So the statement of first law of reflection, that is the incident ray, reflected ray and normal to the plane mirror, normal to the plane mirror, the incident ray, reflected ray and normal lies in one plane. Normal all lies in one plane, and this plane is perpendicular to mirror. This is known as first law of reflection. That means the incident ray, the reflected ray and normal, all three terms are all three terms are lies in one single plane, and this is a single plane, and this single plane which is perpendicular to this mirror, this is known as first law of reflection. If we write the second law of reflection, this is reflection number second law, a law of reflection. Second law, here angle of incident, and this is angle of reflection. So according to second law of reflection, the angle of incident, the angle of incident which is equal to, the angle of incident is equal to angle of reflection for plane mirror. So you can write that is angle of incident I, which is equal to angle of reflection, and this is second law of reflection. This is first law of reflection, and this is second law of reflection. Clear? So these are two important law for reflection. Clear? And this is incident ray. Actually, if there is no obstacle, then light propagate this direction, and this is known as line of action of incident ray. This is known as, sorry, we make it clear. This is known as line of action. Line of action of incident light. Incident ray. Clear? Actually, if suppose there is no obstacle, then light propagate or light passes through a medium which is straight line path. So but there is another medium, and this medium is opaque medium. So and if you draw this is incident line, then this is known as the line of action of incident light, and here this angle is known as angle of deviation, because actually light try to pass this direction. Due to this obstacle, the light change its direction to its original medium. That means the light deviates. This is original path. Light deviates from its original path at an angle. This angle is known as delta. So what is delta? Delta is known as, that is angle of deviation. This is known as angle of deviation, because this is straight line. This is a straight line path. So we already know this total angle which is equal to 180 degree, and angle of incident which is equal to angle of reflection. So we can write I plus R plus delta, that is I plus R plus delta, which is equal to 180 degree, and here that is delta equal to 180 degree minus I minus R, but I equal to R, or you can write that is 180 minus 2I or 2R, and that is known as angle of deviation in case of plane mirror. Clear? That image formed by a plane mirror. Suppose there is a plane mirror like this. We already know what is plane mirror. Okay, this is plane mirror, and one side of the plane mirror is silver. Suppose there is a point object or source. So what is object? First we have to know what is object. Object means all the intersection point of the rays, or all the intersection point of rays. That means suppose these are the ray like this, and like this. Then if we produce this direction, then all the rays are meet at a point. This point is known as object. Clear? And this object is known as, here it is a real object. So if we consider a source here, that means we consider the light which start this point, and this point we can take, that is object. So here there is a object. Clear? Okay. So how image form? on this plane mirror. Actually, if you want to see one object, then we need two rays, minimum two rays to see an object. So first, suppose if you want to draw if the light or source, this is the right, this direction, and which incident normally on the plane mirror, and this is incident ray, this direction. We already know if you draw a normal at this point, then normal also pass this direction. That means the angle of incident here, which is equal to 0 degree. According to law of reflection, if angle of incident 0, then angle of reflection must be 0. That means the ray which is returned back to this same medium. That means if we observe this side, suppose this is observe this side and it is our eye, you observe this side, then it seems that the reflected ray which coming from this direction, if this is mirror, this is incident ray which strike normally at this point, suppose A and this point is O point, then if this is striking normally, then this ray is completely returned back to this sun medium. If you observe this side, it seems to appear that this reflected ray which coming from this point, clear? Again, if you take another point on the plane mirror and if you incident another one ray here, clear? This is incident ray, but here we have to draw a normal, and this is normal, and this is angle of incidence. Suppose this angle theta, then we already know for laws of reflection, the incident ray which is equal to angle of reflection, and this angle, and this ray reflected like this direction, and this angle which is equal to theta, because this is I and this is R. But if you observe this here, because this is eyepiece here. If you look at this point, or if you observe this point, and this reflected ray which it just seems to be coming from this point, if you produce back side of the mirror, then the producing light, the producing ray which meet at a point, and that point is known as image, and this point suppose B. That means this is an object and its image which is back side of the plane mirror. Actually this ray, this is original ray, and this ray reflect this point, so incident this point and reflect back to the original medium. But this ray appears to meet extended ray or producing ray, which appears to meet at a particular point, and that point is known as image. Clear? If this angle theta, this is straight line, and this angle must be theta, because here also a normal, this is perpendicular to this surface. If this angle theta and this angle theta and this angle also theta, we already know if this angle theta, then this angle also theta, and this angle also theta, and this angle is 90 degree. That means two angle are equal, and this angle also equal, and this angle also equal. That means this triangle and this triangle are AOB, and suppose this point C, that means AOC triangle and triangle AOC and triangle BOC are congruent triangle. So you can write the distance from O to A, the distance that is OA, which is equal to distance OB, and here the distance OA is known as, that is object distance, and the distance OB is known as, that is image distance, and the object distance which is denoted by a single letter, that is small u, and the object distance which is denoted by a single letter, that is v. So here the object distance which is represented by u and the image distance which is represented by v. Clear? And you have to remember one thing, the distance, object distance and image distance always measure from the plane mirror. Object from the plane mirror. So we have to object this side and we have to measure this side, because these are two opposite direction. Clear? If we take object distance here which is positive quantity, then image distance will be negative. If image distance negative, then object distance will be positive. Why? Because we measure from this side to this side and this side to this side. But here OA equal to OB. From this relation we can write, that is OA which is equal to minus OB, because these are opposite to each other. And here we can write U equal to minus B. And their magnitude equal, but this is known as sign convention. Clear? So this is the image formed by a plane mirror. Image formed by a plane mirror. Suppose there is a length object, not point object. So the length object, suppose this point A and this point B. So there is a length object which is in front of a plane mirror. Clear? And this distance, suppose this distance is known as object distance and it is denoted by U. We already know, if there is a plane mirror and if there is a point object, then if this distance U, then back side of the plane mirror then form a image, and if this is object. Clear? And if distance U, then this distance is V, that means U equal to B. But they are opposite side, because distance always measured from this plane mirror to this mirror. Clear? Similarly, if this point A, suppose there is 2 points, point A and point B, and the back side of the mirror we can write there is a point, at this point A dash. And if this point B, then image formed at the same height from this from point A and this point which is B dash. So this is the image formed by a image formed by a plane mirror like this. Clear? And this is length object, and this is also, this distance also U. If this distance D and this distance D. If this distance 2 meter and this distance also 2 meter. And here this image which is from back side, and this image we cannot place on a screen. So this image is known as, which is virtual and laterally inverse. If you show your left hand, then the mirror show your right hand. That is known as laterally inverse. And this is virtual object. Clear? Virtual object means, suppose there is a plane mirror and there is a object, point object here. If we take a screen here, this is screen, we cannot place this image on the screen. And that type of image is known as virtual image. Clear? And this is the direction of object this direction, and here also object this direction, and this is known as erect image. Erect, and this is virtual and erect image. Clear? These are also characteristic of plane mirror, and this is the length object. Clear? Again, there is a, I can take another example. Suppose there is a plane mirror like this. There is a plane mirror. This is incident light, and there is a normal. This point is normal, and which is reflected back to the same medium. This is reflected ray. This is incident ray. This is angle of incident. This is angle of reflection. Clear now? If you rotate this plane mirror, because this is plane mirror, if you rotate this plane mirror some angle theta, like this is rotation of another plane mirror, like here theta. if plane mirror rotate at an angle theta and this rotate, this is rotation in this way theta, then the reflected ray rotate, because there is another point normal here, so reflected ray rotate in this direction. This is another reflected ray. Suppose reflected ray, this is new reflected ray due to rotation of plane mirror and it reflect, that is 2 theta. This reflected rotate, that is 2 theta. If you rotate theta angle, then this reflected ray which rotate, that is 2 theta. This is another property of a plane mirror. Clear? So today we discuss all the properties of plane mirror. What is ray, what is beam, what is source. Next class we will start reflection on spherical mirror. Thank you.